what we can do with it. So what is it? Any of you can define what it is?
JavaScript
combined. Yes, please. JavaScript.
transpiler.
JavaScript transpiler.
That's on top of it.
Yeah, like let's get this right. So what is a transpiler?
You're getting older.
Yes, it's a mechanism to keep backward compatibility for JavaScript. So JavaScript is undergoing like more kind of speedy development, and there is a plan of having a release almost every year. And the developers are very eager to use the new features of the language, while the browsers and the JavaScript platform take their time to catch up with the new standards. So the transpiler is taking a JavaScript that has later features and basically converting them to the JavaScript that is widely used. For example, these days there is ES 2015, which is the official standard, but the widely used standard is ES5. So you write your script, you can write now using AS6 and take advantage of the new features, and you use a transpiler to compile it to the previous version. So Node.js, no, it has almost nothing to do with that. Okay, another attempt. What is it? Yes, please.
They took the Chrome JavaScript
runtime. Yep.
Yeah, and they took it was virgin 8, and
yep.
then they added to it. They removed the limitation to access file and stuff like that, and they made it as a standalone.
Yes. Yeah, that is basically the basic idea. Is they took out the JavaScript traditionally used to be kind of limited to the browser, and it runs in the context of the browser. And to do, the capabilities that we have seen, such as client-side validation, Ajax, and so on. So they took it out, and you can run it on the desktop, on the server, you can run it anywhere. And the core of it is the JavaScript runtime that comes with Chrome. I think the name of it is V8, it's not the version. That's my understanding. So V8 is the name. Version could be, I don't know, 13, 14 version. So the engine itself, as a marketing term, Google named it V8. So they took this V8, they added some extra libraries to it. We will see what these libraries are. Basically, they added extra C++. V8 is a C++ program. It's open source. You can download it if you wish. They added more open source libraries to do other things that I will explain shortly. On top of it, they added some JavaScript modules, reusable modules that other people can use, and people started developing more modules and making them open source and available to everyone. And then you can build your own application on top of Node.js. So, in a simple way, Node.js allows you to program, let's say, the server-side components of your web application using JavaScript. So the initial, there are many motivations that drove this initiative. One of the motivations is you have a unified programming language across the whole end-to-end application. So instead of using Java on the back end, or .NET, or PHP, or you name it, Python, or Ruby, or other platforms, other languages, and learning other languages, you just learn JavaScript and use it both on the client side and the server side. That's one of the motivations, but that's not really the most one. Of course, it is. It is a very important motivation, but there was another motivation, which is to do with scalability and performance. Scalability, the ability to handle more load, on more users by adding more resources or scaling out to multiple servers in a cluster, and also to improve the performance. Particularly in terms of reducing the response time. And I will explain why Node.js helps us to do this. Okay, so hopefully this guy will work. Okay, first of all, this slide is based on many slides and many books. I'll have to have the time to list them, but so many, plus my own understanding. Okay, so from here, we will define what Node.js, what is the motivation behind it, what is its architecture. But just from this little diagram, you can see that where people are heading with this is that on the client side, will be heavily based on JavaScript, as you are seeing now with your Angular framework, with jQuery and others. On the server side, you will have Node.js, and it's also JavaScript on the server side. On the database side, there are many databases, but one in particular is getting very, very popular. It's called MongoDB. It's a document-oriented database, and also stores the data as a JSON objects. So you have JavaScript as the programming language and JSON as the data format, cross the end-to-end of your application. That is where what is the offering that Node.js is bringing to the table. And this basically gave birth to a new stack of technologies to build web application, and this stack is called the mean stack. Mongo for the database, Express and Node on the server side. I will explain what this Express is. Express is just another module that sits on top of Node.js to make it easier to develop web applications. And we have Angular. It's a very important framework in this new stack. And we have Node. So the mean stack is the future stack that people are moving to gradually. Currently, the current stack that is dominating the web, maybe 90% of the web, is powered by the current stack. It's called LAMP stack.
Which is Linux, Apache.
Yes, Linux, Apache, MySQL, and PHP, Python, mainly PHP, but you can even put in here Python and PHP. So this is not really kind of dying, it is still there. I'm not sure, more than 90% of the web is powered by this. Even Java and .NET, they have very small market share. So, but for new projects and for API, really people are taking this very, very seriously. And I will show you some examples of big companies adopting this and reporting the benefits that they have already starting to notice. So, to summarize, Node.js is really pushing and kind of help people to bring about this new stack called the mean stack. And the mean stack will gradually kind of compete, at least for now, compete and eventually gradually take over this LAMP stack, especially for new projects. It's a serious alternative for you, especially if you are starting a new project. Okay, so what is Node.js? It is a cross-platform environment for hosting and developing JavaScript-based application. It is truly cross-platform. You can run it on Windows, Linux, Unix, all the platforms. It offers an end-to-end JavaScript environment. It is a really very suitable when you have an I/O heavy or I/O, what do we call it? What is the term? Kind of an I/O bound application. An application that does a lot of reading and writing, either from disk or from a database or from the network. And we will see why Node.js is really very good when you have a network and I/O-based application. It is heavily based on these two major tenets or principles. It is a non-blocking. It is a really adopts an asynchronous programming language, which is one of the foundations of JavaScript, and it is event-driven. So everything is asynchronous, and you can respond to events. For example, when you are reading a file, you are not reading it synchronously. You ask for the file to be read, and every time a chunk is read, an event will be raised to you with the chunk that has been read. So reading and writing is asynchronous, and I will explain this further. It is open source, and it is managed by these two major companies, Node.js Foundation and Joint, and it is available here. Okay, why it is very, very popular? It is very light, very lightweight. Those of you who have experience with something like Java EE, especially if you are going with WebSphere or Glassfish, or very heavy way to install it, very heavy way to maintain it. Node.js is very light. You already experienced with it. Very easy to download, install, and get up and running with it. It is very, very fast. It is easy once you, of course, learn it. It has a huge community behind it. And it is based on JavaScript. It is scalable. It is cross-platform. All these features made it very, very popular. This is what people are using it for, according to one of the very innovative company working in this space called Strong Loop, recently bought by IBM. This diagram comes from this report that they have in their website. This is what people are using it for building API, application programming interfaces, to connect applications together. So the backend could be any technology, and you use Node.js to basically integrate applications that are written in any other platform. Second thing, it is really heavily used as a back-end for mobile services. So you have a native application like iOS or Android, and the back-end components are heavily using Node.js. It is widely used for single-page applications, because in a single-page application, you only have the shell page, and then after that there is JSON going back and forth. So it makes sense to just use JavaScript all along in the path. It is also used heavily in the Internet of Things and sensors, sensor networks, and Internet of Things. Now, these are from the same source, this Strong Loop, saying these are the people that are really using it. Big companies in different industries are heavily using it. Another proof that it is very widely used and it is here to stay, most of the cloud providers, including Microsoft, Google, Amazon, even the small ones, they all providing Node.js as a platform as a service. You can build your Node.js application and host it in their servers in a cloud environment. So this all shows the importance of this technology. Widely adopted, and it's growing significantly. And this is another proof. This is a screenshot I took yesterday. I'm sure the number has gone up since then. This is the npmjs.com. This is where these modules that people are building and publishing for others to use. I'm sure you have some of the numbers come from you, especially in the last few days. So you can see here the number of packages that are available, more than 200,000 packages. So don't be too scared. The top ones are only 12 or 20 that you need to know. In the last month, more than 3 billion downloads. Just per day, have a look at this. Per day, 134 million downloads. These are all indicators of the popularity of this framework. And it's growing. Now, these are really use cases that companies have published reports and presentations about. PayPal used to have their implementation in Java, and they moved to Node.js. And this is what they have reported. 2 times faster development with less developers. Now, very good news for Java developers. 33% less code in terms of code size, less files. 2 times, like speed is improved twice. The response time means dropped. And the average response time decreased by 35%. So in terms of scalability, in terms of productivity, it brought these benefits. There are many other case studies. I just selected this one as an example. Okay, so because of these benefits and this popularity, this traditional LAMP stack is now under pressure, especially, as I said, for new development. So the reason why is because you have to have multiple languages. You have, for example, in here in an Apache server, you have to use PHP or Python or other language. On the client side, you use JavaScript. On the database side, you use SQL. And also, you have to do data transformation from JSON to some PHP data structures. From PHP data structures, you have to kind of feed them and construct some SQL statement to submit them to the database. So a lot of glue, a lot of effort, much more effort due to this. At least dealing with 3 languages, you have to do lots of data transformation. And scaling out is also problematic. I will explain why scaling out is problematic with this stack. Now with the new stack that is emerging and getting more popularity, it's called the mean stack. In the mean stack, what we have is JSON as the data format. There is no transformation whatsoever. You get JSON from the server, you bind it to your UI and you show it directly. When you are submitting data from your application to the server, it's JSON. And then when the server gets it and wants to persist it, it persists it as JSON in the database. So JSON all along. And in terms of programming, the client side, as you already appreciate, your Angular application that you are doing now, 90% is JavaScript, a little bit of HTML. And Node.js that you will do in your project and in your homework 4 will be heavily JavaScript. And the database, I'm talking here. Database is stored as JSON, which is a binary JSON, but really when you deal with it through the API, it is JSON, as we will see shortly through the demos. So this is what the mean stack really is. Although I don't like this, it should be the other way around, or maybe vertical. It doesn't matter. The database layer is MongoDB. The application layer is Express, which is a module on top of Node.js. And there is Mongoose, which is another module to interact with MongoDB. And on the client side, you have Angular. That is the mean stack that is currently trying to replace the LAMP stack. Now, this is just to recap. So you have your Angular JS application, a single page application. You have the shell page loaded once, and then from that time onward, you talk to the Node.js server, exchanging JSON messages. And then the application server talks to the MongoDB and read and write JSON. So JSON all along and JavaScript all along. Very good news for many developers. So these are the advantages that are really pushing the adoption of Angular. It has very flexible architecture. I will explain it shortly. Deployment Very easy. Just copy your files and paste them on a server. There's no installation or complex stuff. And if you depend on something, you will use npm to bring your dependencies. You're already familiar with this story. Very, very active community, as you can see, more than two, as shown by the statistics. You can just go to npmjs.com and you will see the statistics yourself. Now, where people are using this Node.js, two major scenarios. As, for example, when you see a job ad in this space, you will either be a front-end developer using Node.js to drive your workflow. So far, you have not used Node.js to develop the server side, but you already use the Node.js as an enabler of your development workflow. So to bring down your dependency, define and bring down your dependencies, to do the compiling. In more advanced scenarios, if you are using Sass or other flavor of CSS, to convert it to plain CSS, for example. You can do minification of the JavaScript before you deliver it to the production environment. And so you can do uglify, which is taking the JavaScript and making it a little bit too scary and not very meaningful by like shuffling the variable names and function names. So if somebody looks at them, much harder for them to work out the logic or to copy some of the stuff from your application. So there are so many tools out there that drives this development workflow, and these tools are built on top of Node.js. So even if you are not interested in using Node.js as your application server, it is still very, very useful tool as a kind of an enabler of a better development workflow. And we have seen it, and you can see all platforms, like including Microsoft Visual Studio, WebStorm, of course, even the Java people, they are all adopting this as an enabler of client-side development. And there are a lot of tools. Unfortunately, we didn't have time to look at them, but just be aware. At least this GAP, you have kind of one of the examples, or two of the examples, the hero example and the travel example. It uses this GAP to define the steps how the application will be built. So this GAP, you can define tasks. They call them task runners. And you say, what are the steps? When you want to run your application, what steps do you take? For example, you compile TypeScript to JavaScript. If you are using Sass, you compile Sass to CSS. And then you launch Node.js and you launch Node.js and you watch for any changes to the folders. If there is any change, auto-recompile and refresh the web page. So all of this is making your development experience more productive. Okay? So as I mentioned, there are two major scenarios where you will encounter Node.js. Either you encounter it as a kind of an enabler of a better development workflow, or you will encounter it on the server side as your technology to build your server-side component. So these are the two major components, two major scenarios where you will come across Node.js. And you already came across it and you're already using it so far. Okay, now the Node.js architecture. What is it made up of? What are the elements we find in this Node.js? So first of all, this is the core of it is the V8, which is the Google JavaScript engine. Plus, they use this open source library called libuv. And this libuv allows us to do asynchronous input and output. Asynchronous means when I read a file, when I say most of you have wrote some program at a certain stage to read a file. So when you read a file, typically you block until the whole file is read. You do whatever you do, whatever you want to do with the data that you have read. Maybe you put it in an array, or you search for some stuff while you're reading, whatever you want to do with it. So that your program blocks and waits until the whole file is actually read or written to disk. Now, from intuitively and from your database course also, it has been stressed that your input-output or interacting with the disk or interacting with the network is the bottleneck in terms of performance. So, like as you saw, those of you or most of you have done or are doing database, the whole database engine has been architected to overcome that limitation, to reduce the impact of this speed gap between the memory and CPU and the disk. So, what AngularJS, one of the critical pillars on which it relies, is this asynchronous I/O. So when I read a file using Node.js, you don't block. So you just say, read a file, and you continue the program execution. And what happens is, this reading of the file will be done asynchronously, and each time a block of the file is read, a callback will be called from your program to handle that chunk of data that has been read. Same thing if you are reading from the network or reading from a database, or it's all asynchronous. There is a nice diagram that will explain this nicely. And this asynchronous input and output, it relies on this open source library called libuv. It's a high-performance cross-platform event I/O library. On top of that, they added some extra C++ code and some extra JavaScript modules to make the platform accessible to developers. So these three ingredients make up Node.js. Okay? So a little bit more details. It's all C and C++, mainly open source libraries bundled together. And plus you have some JavaScript modules on top of this platform. More than 90% is C and C++. Only the modules that are taking advantage of the functionality here and exposing them to the programmers is on JavaScript. The rest is C and C++. Okay, here is the main motivation of Node.js, is to address the traditional way web servers work. So the traditional way web servers work, they are multi-threaded servers. What this multi-threaded means, what does it mean? Let us see. Many threads at a time. What do we need these threads for?
Requests.
Sorry?
Requests.
Thank you very much. So every request that comes, it has its own thread. So if you have 1,000 requests, you have 1,000 threads. And these threads are in a pool. When the thread finishes, it comes back to the pool. So the more node you have, more threads you need. Of course, when I say thread, it needs memory, it needs CPU. And the problem is, most of the time, these threads is just waiting. Waiting for what?
User instruction.
No, waiting for the CPU.
No. You're waiting for the I/O. No, for the user. No, the user request comes. Okay, arrive to the server. To handle the request, what the server does? It creates a new thread and say, here is a request. Please deal with it and send the reply. Because the server needs to always be listening on one thread. It does not use that thread to process the request. It hands over the request to a new thread. That thread needs to read from the file system, needs to talk to the database. File system is slow. So the thread is blocking and waiting for the file system to respond, or database to respond, or another component on a network to respond. So the more requests you have, more threads you have, and most of their time are waiting for I/O operations to complete. So this is not very efficient because they are memory hungry, and at a certain stage you will hit your limit in terms of concurrency. There is a number of threads that you can spin off on your server. And if they were fully utilized, you can't do much about it. But the reality is that most of their time is spent on waiting for data to come from the disk, or to come from another server on the network, or to come from the database. And that waiting is just a waste of time. Okay? So instead, Node.js took a different approach. So first of all, Node.js is single-threaded web server. There is only one single thread that receives the requests. When the request is received, basically handling the requests will be done asynchronously, and it will be given to, you have a pool of threads. What I want to say here, there is one thread that handles all the incoming requests. But when that event handling needs to do any asynchronous operation, like for example, reading from a file, or reading from a database, or talking to another component through the network, it's not done in this main thread. It is outsourced to one of the threads in this pool, specialized. These threads are specialized to do I/O operations. Okay? Now, this thread basically has a queue where when I ask one of these threads to do the reading on my behalf, when the data arrives, it get your request that is pending in this thread will be called back to continue. So basically what I want to say here, there is no one request, one thread. No more for each request it creates a thread. There is only one thread that handles all incoming requests. When this incoming request needs an I/O operation, that I/O operation will be handed over to one of the threads in the pool. These threads in the pool will do the I/O operation in asynchronous way. When the data is ready, it will call back your callback that you provided when you called one of these threads. It will become a little bit clearer when we do the actual programming in this model. So the main thing I want you to recall for now is that a Node.js application or a Node.js web server is a single-threaded. It doesn't mean it has only one thread. It has one thread that handles all the requests, but it has a thread pool to handle input and output. So you can already see here, that's why if your request handling is doing any heavy computation, you should not do it synchronously, because you will be blocking everybody else. So you have to do everything asynchronously. So reading and writing, heavy computations, interacting with database, everything is asynchronous. And so it can be delegated to one of the threads and leave the main thread always up and running, not blocking with some heavy computation or heavy tasks. So that is the main idea of Node.js. So, and this idea really proved from practice that it is more scalable, much faster, and it's less resource consumption compared to the multi-threaded servers. Okay. Now, with this basic understanding, let us now, before we go into a more practical usage of Node.js, how we use it to develop server-side applications, let's have a look at some very fundamental concepts that Node.js relies on. First, the concept of a module, that the application is made up of modules. Similar concept, modularity, that you're all familiar with, that you break your application into different components, and then one component can import other components. So it's exactly the same as what you do in now, for example, in your homework. You are not putting all your code in one place. You are breaking it down into multiple files. And one file exports some functionality, and the other file imports it. The other foundation of Node.js, everything is asynchronous. Even if you have some heavy computation, you never try to do it synchronously, because it will block, the whole application will come to a halt. You try to do everything asynchronous. I/O definitely must be asynchronous. All I/O, reading, writing to disk, or reading, writing from the network. It is all event-driven. You listen to certain events, and you react to them. So the programming model is really event-driven. So these two are not really too strange for you. You're kind of already familiar with them. But we will go a little bit deeper into them. So let's start with the module system. Very, very powerful, as you will see shortly. So modules are a way of encapsulating functionality. Functionality that is functionally related, you put it in one file. That file is basically a module, and then you can reuse it in another file. That is the basic concept. So there are many, many modules that are in this npm.js website. You can download them anytime you want using npm install. You're already familiar with it. For example, there is, and there are some modules that come with Node.js. When you install Node.js, already has some built-in modules, and you can add some more using npm, Node Package Manager. For example, here there is a module called HTTP. If I want to basically handle HTTP requests, GET requests and POST requests, I will use the HTTP module. If I want to have a two-way multiplex connection between the client and the server, I can use the socket IO. It's another module. So some of the modules come with Node.js. Others, you will download them through npm, using npm. Others, you will build yourself. That is the idea. Okay, this is how a module looks like. You will see that is a bit different than the way it is done in AS 2015. Maybe this might change in the future, because AS 2015 adoption is still at early stages. So here is how it works. So here is your module. You have something called circle, and this circle is able to compute the area of circle. So I have here a function that is able to compute the area. It takes the radius and returns pi times radius times radius. Okay, and I have another one for circumference. So this very similar to AS 2015. You basically export these functions to the outside world, and in the clients that will be using this module, we don't have import. This is a new in AS 2015. No, in fact, you can use the new syntax, but you have to transpile it. When you transpile it, it will use this old syntax. All right. So in the client, what you do is you require, and you provide the path. So in here, when you see /, which means the module and the client are on the same folder. So this script here will be loaded in this variable circle, and these two methods will be available, area and circumference. And I can call them. For example, here, circle.area4. That is the concept of a module. Very, very powerful. The whole application will be built on modules, and it will rely on third-party modules that you can acquire through NPM. So, anything preceded by /, it means in the current folder. Otherwise, if you want to specify an absolute path, you can, but you don't use the dot, you use the slash and put the full path. But the most cases, you always refer to the current folder and go from there. Either go backward by doing // or // and put the subfolders. And if you don't see this slash or // then there are two cases. Either the module that you are trying to use is part of Node.js, or it has been already downloaded through NPM. And if you remember, when you use NPM and NPM install, it basically puts all the modules, as I can show you here, it puts all the modules under node_modules. And when you require them, you don't need to specify the path. Just specify the name. So for example, in here, as I showed you here, I didn't specify any path. The module loader, that is part of Node.js, it knows where to get them. It will try to get them from node_modules, or it will try to get them from the node installation. And Node comes with a lot of built-in modules as well. Okay, this is another example here. Anything I don't export is private, which means it's not visible in the file where you require these exported functions. So in here I'm exporting an object, and this object has a property, we assign 42 to it, and it has a method, add. And from the client, I do require, and then I can either access the property or I can call the method. So the module exports, and the client or the file that wants to use this module will do a require, and then it will have access to the properties and the methods. Okay, that's the first foundation. Everything should be modular, and you have modules that you can compose them to create your application. Second thing, everything should be asynchronous. I/O, in particular, heavy computation, should be asynchronous. Okay, so you really need to be careful of this. If you are not careful, you can easily, I will come back to this, you can easily do something like this and block the whole application. If you go in your application and do something heavy processing, like a loop, and in this loop you do some heavy processing that is not asynchronous, then the whole application, all other clients will be affected. So you need to be very, very careful. Because it is a really single-threaded application. So that's why, let me explain it one more time here. So the way it works, your Node application requests the runtime to do some processing. When you request anything, like reading a file or retrieving some data from a database, you always do a request and give a callback. When the data is ready, Node.js will call you back to give you the results. So when you request, you never request something and wait for the reply immediately. Give a callback and move on. That is the main idea. So Node.js has this event loop. Sorry, just one second. In the Piazza, I posted one very, very important video. I really, really encourage you to watch it, because it really explains it very, very well, the idea of event loop. So when a request comes, the the request is asking Node.js to perform some operation, and it's providing a callback. Now, Node.js is one thread. So what it does, it delegates. What it will do, it will delegate this main thread. It will delegate your work to one of the threads in the pool. And when the results come back, and basically your callback goes into a queue. When the results come back, it will be picked up from the queue, and the results will be given to it to do some further processing. That is the idea. Okay. Yes, please.
What about the call stack? Is it also here? Like in the video you shared, it explained that the event loop is only when there's an asynchronous stuff.
Yes.
And then what about is there a big call stack? Because it's single threaded, right?
Yes.
It's not highlighted here. But is it the blue thing itself?
It's not highlighted. You're right. It's not highlighted here. It's basically for each request there will be its call stack.
Each has its own? It's one thread.
No, sorry, one stack, because yes, that's the multi-threaded. So in here we have one call stack. So what do we have? So the call stack, we have functions calling each other. What about the new functions that come? My understanding is it should be queued, because the call stack is when you have functions calling each other, and like the stack, the last function that you call is the other way around. The call stack. Let's see.
It's a pop. So you keep building until then you read down until you finish.
The last one that you call is the one on top?
The last one you reach is the one on the top, and then you start finishing it.
But the results will come from up, from down. The earlier functions that you call
is down.
Yes, and they will produce some results. Yes, and they will propagate up. Now, when you have multiple requests from different users coming from different,
each other.
so
Waiting for each other. So they will go from there.
but they are not dependent. Like every caller has different calling different functions. Let's say.
Yes, but you want you call function A,
Yep.
that will do its own recursive stuff.
Yes.
Okay, and then I call B. B won't be called until you finish A, right?
Yes. So it is more, for me, the way I understand, it's more like kind of requests are kind of queued until they get their chance. Once they get their chance into the main thread, they will have a call stack. Yeah.
So the event loop is the one that will bring, okay, finished A now.
Yes.
give me- okay.
Yes. And the ones that are waiting for some data to come back, they will go to the queue. So there is a queue and there is the call stack. My understanding, the call stack is for when handling one particular request. Okay, and when that request is waiting for some I/O to come back, it will go back to the queue until it gets its chance. Okay, that is my understanding. Okay, the main thing. Let's just summarize this very quickly. Like the Node.js has this main thread that receives the requests. Okay, that main thread will ask, your request will be a function call. Do this for me. Now, anything that is synchronous, like for example, do 10 plus 5, this is not asynchronous. It will do it and then move to the next step of your function. Once it reaches a stage where it needs to do some I/O or something asynchronous, the main thread will delegate it to one of the threads to do it, and when the results are ready, your request goes into a queue. When the results come back, your request will be wakes up again, given the input that came back from from one of the threads that handled your request, and then your function is allowed to move forward. Okay, that is the main idea. So I/O, you must use it. We have to use it whenever we have I/O operations, heavy computation, or anything that requires blocking. Because you have one thread, if you block it, that you cannot. Any other request will be waiting, will be queued, waiting for your blocking code to continue. So the idea here, this model only works because it is assuming it is asynchronous program, heavily asynchronous. If it is heavily synchronous, this will, of course, will not work at all, because you cannot do in single thread handle concurrent requests. But because you are assuming requests require some asynchronous interactions, then you can keep them waiting while you handle another request. But if they all do it synchronous, then it defeats the purpose. Yeah. So that's why asynchronous programming is very, very important to really understand and practice. All right. So coming back to this, as a new Node.js developer, you really try your best not to have long-running code or anything heavy computation done synchronously. Always try to push it to be asynchronous. For example, in here, if you are processing multiple files, you might be coming from Java or Python background. You will do a loop and go through those files. But in a Node.js, you will read them you need to read them asynchronously. So there is a read. In Node.js there are two functions. For example, for reading files, there is a read file sync, and there is a read file. So by default it is asynchronous, but just in very unlikely case you want to do it synchronously, you can do it this way. But while you're doing this, you are blocking everybody else. So the proper way of doing it is this way. So what you do is you want to do file system operation, reading and writing to a file, to the file system. First of all, you use a module called fs. So you go and require that module and assign it to a variable. And then that module has a function called read file. Give it the file you want to read. Optionally, you can give it the encoding if it has non-English characters. And then you provide a callback function. For some reason, I'm not sure, I don't know the wisdom, but they always put the error handler first, then the data. So a bit pessimistic that things will go wrong. So in here, if it is an error, then you do something else, you handle the data. Okay? So
I think just to make sure that you actually get the error and the data. Because if it's the data first, you just put the data, ignore the error.
yeah, you're right, thank you. Yes, it makes sense, yes. So in here, it forces you to always think about error handling. So if it is optional, if it is made last and optional, most likely you're right. Most developers will ignore it. But now, because you have to put it first, then you will. It kind of pushes you to do error handling in your code. So most of the Node.js programming, it takes this style. You call some function, you don't wait for it, give it a callback for Node.js to call you back when the results are ready. That is the idea. Okay, so now file system, like a little bit about file system, you might not use it heavily. Typically in a real application, you will use some kind of database. But let me just see if I can try, or I can kind of, just to show you a couple of small things before I go into more demos. Here is the shell. So Node.js, here is Node.js, Node. You just run it using this command, node. It gives you this command. And then here, you basically using JavaScript now. You can do whatever you want to do in JavaScript interpreter, interactively. So I can do here console.log underscore underscore, what is the name? Dir name. Gives you the current directory name. No. Let me, sorry. Do I need any other dependency? Okay. Not sure. Okay. Okay, no problem. There is an alternative way to do this, at least for the current directory. There is under the process. So here is the process. All right. What is? Yes, I escaped. Sorry, let me open it again. Okay, it's hiding. It's hiding here. Okay. So if you use a process is a built-in object in Node.js. So there are some built-in objects that you will not find in the browser, for example. Yeah, this will give you the current working directory, process.cwd. A couple of other useful if you want to change directory, you can use process.change directory. If you want to know where is Node.js installed, you can do process.exec path. Now, in terms of reading and writing to files, you will be using the fs module, and the way you import it is you declare a variable and you require the fs module. And the fs module will be loaded into this variable, and then you can use the methods on this fs module to do file read and write operations. So here is an example. So most likely the directory name most likely it requires this fs. No, not really. Because anything that fs, if you want to access it, you have to do fs dot. So I'm not sure why it is not really working, but it doesn't matter. In here is an example of reading a file. So what you do is you require the fs module, and then you go and say, go ahead and create a read stream. This is if in case you have a large file. You don't want to read it in one go using a read file. You want to read it in chunks. So to do this, you do a read stream, and then what you subscribe to two events. One event will give you each chunk as it gets read. This event is called data event. And one event is the end, when the file is fully read. Okay? So you can see here the power of async. This is what I mean really by asynchronous programming. So one of the threads will take care of reading the file, and when the data is ready, it's given back to you to handle it. And when the file is fully read, you will get notified through this end event. So it's a really asynchronous event-based program. That's what really Node.js, and that's what JavaScript is all about. Here is another example of writing. Very, very powerful API, very concise. I want to copy basically one file to another. So what I do is I create a read stream, and I create a write stream. So I want to copy foo into bar, and then I just connect them using a pipe. And I say, connect this read stream with the write stream. And this is how you copy files, using streams. And it will be done asynchronously. There's no blocking on your program. This is a final example of dealing with files. You can also zip a file, take a file and create a zip of it. So what you do is you are relying on two modules. FS modules to read and write, and the zlib module to do the compression. So what you do here is you are creating a compressor, and you are creating a read stream and a write stream, and then you connect them. You say, take the read stream, pipe it to the compressor intermediary, and then push the result to the output. And this will be done asynchronously on your behalf. So you can see very high-level API, very powerful API, and relies on built-in modules and modules that come from the community through NPM. Is clear so far? This is not the heavy lifting we want to focus on in this course, because we want to use Node.js for web development. But just to emphasize the fact that it is asynchronous and event-based. That is the programming model adopted by Node.js. Now, to be able to build a server-side web application using Node.js, what you can do is, first of all, you can do so, let me first show you. You can build a web server very, very easily. A few lines of code. A fully functional web server that you can use in real life. So what you do is, you go ahead and require the HTTP module, which is a built-in module in Node.js. And then you say, using this module, go ahead and create a server. Okay? And give this server a callback. If somebody comes and sends a request to this server, what we want to do is, we want to take, so this callback takes a function that has two parameters. A request to read what's coming from the client, and the response to send back the reply. So those of you familiar with, what they call it, servlets, will be very familiar. But it's, instead of having Glassfish or WebSphere and a couple of hours or maybe days of installing and setting up and so on, in here, just in few lines, you have a fully working server. So keep on writing there. Here it is. I'm writing this line, followed by this line. I want to know which method the requester used to come to my web server. Is it get or post or put or whatever it is? And then what URL they have requested when they came to my server. And then I end this. Okay. Here it is. Now, what I'm doing here, now up to here, let me just show you. This is another server, more sophisticated. All right, here it is, comment with block, and I'll just uncomment this one. This is my web server up and running. So if I try to run it, which port? 3000. So let me just run it. Although I should have said listening on port 3000. So if I go to basically localhost port 3000, I should get that hello node. The method that I use to get to the server is get, and the URL that was requested is slash. Okay, this will handle any URL. It doesn't matter. This time, this is the URL. So, very simple way of creating a server all you do require the HTTP module, go ahead and create a server and provide a callback. This callback function has two parameters. The request gives you all the parameters came from the client when they made the request, and the response is a way for you to push a reply to the client. Now, of course, this is a kind of a baby server you have to do if you want to handle multiple requests. Based on the URL and based on the method, you do a switch and say if somebody requests about, send them the about page. If somebody requested the time, what's the time now? Send them the current time. Well, depending on the URL, depending on the verb. So you can build a very sophisticated web server based on very, very simple API. Now, this is not very productive. The basic built-in way of doing it using Node.js. To be more productive, the community has built extra modules that you can use to build web applications. And there are many, many modules, but the most popular one is called Express. And this Express, it was developed mainly by this company called Strong Loop. They are pioneer in this area of Node.js, and they, as I said, they have been bought by IBM. And this Express module allows you to build basically a much larger application, much larger web application in a more sophisticated way. And the idea goes like this. So your request will come. The first component that will receive your request is called the router. Similar concept to the router on the client, but this router is on the server. It says for this URL, this is the function that will handle it. For this URL, this is the function that will handle it. So it maps, the router is the core component. It maps a URL with a function. That's it, that's how it works. And these functions, you can refer to some views. Remember views? It's basically a template. A template which is just HTML with some templates, typically with the curly braces. And you take an object and you give it to the template to generate the full HTML. That is the idea of Express. There's a router that maps every URL with a function. And these functions can render views. Views are HTML pages with the placeholders. We feed them the data, and then we produce the full HTML. Okay? So let me show you this in a concrete example very quickly, and then we move forward. Here is no, there is still not this one. Here it is. All right. Here is how it goes. I will explain this gradually, but for now, I want to build a really. Let me first run it, and then I will explain it. So let me run it this way. Strange, it should give me, okay. So it's running and it's listening on port 9090. Okay. So what I have here, this is a fully functional application. This is, those of you who are familiar with Scrum, which is like a development process or methodology, where every day when you start the work, you have a stand-up meeting. You don't even sit, just 5 minutes. Everyone has like maximum 5 minutes. They just say what they have worked on yesterday, what they would work on today, and is there any obstacles, like delaying them or preventing them from reaching their goal for today. And that is what stand-up meeting is. And this system allows you to take little notes about that stand-up meeting. So you will say, this is the member of the team, one of the members, and this is the project they are working on, and this is what they have done yesterday, npm Node.js plus npm. What they will do today, smart, and then right, all not working. All right, that's it. Save. Let me put another one like Zainab. Save it, and it shows up in the list here. And also I can go and filter, let's say only Zainab, okay, or go to Ali. All right, and behind it there is a database. So let me just show you the full story, and then I will explain this. So here is my stand-up notes. This is a MongoDB database, like a document-oriented database, where my data is stored as documents. So let me just refresh this. These are my stand-up meetings. No. So I just want, here, stand-ups. Open. No, sorry. I'm still okay. Okay, here I have two entries in there. This is the ID of every entry. The ID is auto-generated, and you can see the entry for Ali when it was done and everything, and the entry for Zainab when it was done and everything. So we will go through this, and through this example we will learn the basics of a Node.js development to build a web application using Express as the framework to build the application. So let me just walk through a little bit, and then I'll give you a break. Let me just to move this a little bit forward. So instead of using the built-in HTTP module that comes with Node.js, which has limitations, you have to do a lot of coding to get anything up and running quickly. Instead, people are using third-party modules to speed up their development. So one of these there are so many, as I said. The most popular is Express. So first of all, what you do is of course, you will do npm express. That story is already, hopefully, is familiar to you. That our application relies on Express. So to make this, just to remind you, let me just come here and stop this one. All right. So I can do here npm install the name of the framework, Express, and I save it in the package.json by doing this save. If I press enter, it will download this framework and add it to node_modules, and it will add an entry under the dependencies of my program. Yes, please.
Victor, why doesn't save it to the package.json? Just what's the point of installing a package without adding it to the package.json?
Okay. Good question. Because sometimes you want to install some package globally, which means not per application. You install it in the node folder, and all applications will have access to it. So, in fact, in a real life, some of the modules will be global, some of them are application specific. So that's why you might not want to save it as well. But in here you have flag. It's up to you to decide. So if I want to make Express global, all I do when I install it, I do -G. Maybe in some of the examples you have seen this. And this will make Express global, and I don't need to put it as a dependency in every program. Okay, so you have the flexibility. All right. So once you do so, I will come back to this and explain it later. For now, we will just focus on the Express. Then, then what I will be doing is I'll define my routes. Remember, my router is the main component that will receive the requests. And then based on the URL, it will send you to different functions. It will call different functions depending on the URL. So instead of putting the router inside the same file, what did I do? I put them in a separate file. What did I call the file? Routes. And where is this file? Under subfolder called routes, just for organization purposes. So let's go to that folder. Here is routes, and there is a file called routes. Here, have a look. What it's doing here, it says, okay, if somebody comes to a slash with the GET request, I want you to run this function. If somebody comes to the same slash, but this time using POST, I want you to call this function. And by the way, this function, I don't want to put my logic in the router. Where do I put the logic? In the controller. So there is another class called controller where the logic is actually coded. So what I have here, the typical architecture, is I have a router. The router defines the route and the functions to be called. Now, these functions, we don't put the logic in them. We put a logic in a separate file. In this case, let's say we call it controller. And this file, this is where we put our logic. Okay? So you can see here the router. How do I create a router? I go to Express and say router. This will create a router. And then I go and configure it. I map every URL with function call. And here, if somebody goes to /new nodes, I will call this function. If somebody comes to post a new node, I will call this function. So that's the role of the router. Where is the actual logic? For example, here, if somebody comes to slash, we will go and list all the stand-up meeting nodes. And if I want to know how I am getting that list, it is here in this file called controller. So if I go under controller, I'll find a method called list. Okay? In this list, I'm putting the logic how I get my list. And if I go to another route, let's say new node. And here I say get a new node, and this is the method that handles it. So it's just in time. You can put everything in one file if you wish, but to keep things organized and under control and keep the complexity under control, you have at least 3 files. The app file, that is basically the root, the main, where your application will start from. You have the routes, where you define your routes, and you have the controller class, where you define your logic, your business logic, your computation logic, your reading and writing logic. Okay? At least you have these 3 files. All right. So let us look at the first thing. Let us look at this first route, which is the slash. If somebody comes to the root of our application, let's go there. You can see what this function is doing. And a couple of things are going on there. It creates a query. This query will be going to the database, by the way, to the to the MongoDB database. It will say, please create a query for me, and I want you to sort the results based on created on. I want you to only bring 12. I don't want all of them. The last 12. Okay? And then go ahead and execute. When you go ahead and execute, it is asynchronous. Remember, whenever you are dealing with input and output, it must be asynchronous. So I'll go ahead and say, please go ahead and execute this query. And whenever the results come back, later on the future, call me back. And here is the callback function. As Nazar said, we start with the error, so we don't forget error handling, and then you get your results. At what I'm doing here, I go to the response and call this method a render. Can you see it? And what is this index? Is the view, is the page, is the template. Here's my page, and here is the results. So I'm giving an object to this page. This object has two properties, the title and some list of nodes. And you can tell what the template will be doing. We'll be looping through these and displaying in some kind of declarative way. So let me show you the template. So the template will be under views. Have a look at the views. Here is the views, and here is the index. You can see here the index. Here is the index. So similar to Angular syntax, kind of, the template uses the curly braces to access the properties of the object that is being sent to the template. So here is remember that this guy is sending us title. This is how we read the title. This controller is also sending us notes. This notes is a list. So somehow I need to look through it and convert it to rows. Each item in the list will be a row in the table. And here is how it is done. So here is my title. Sorry, here is my title. Where is it? Sorry. Yes, here is the title in the header of the page. And this is just the menu. It's hard-coded stuff. And all this stuff is hard-coded. And here are my notes. A bit similar to kind of Angular. They all kind of copying from each other. So here for each node in nodes, I am displaying the node member, the project, what they did yesterday, what they did today, and what is the problem they are facing. And then I close the loop. Okay? Now, for the views, you are not restricted to this. There are so many templates you pick and choose from. So there is Jade that I don't like. It's up to you what you like. This Jade is not really HTML. It's a bit... I don't like it at all. Maybe some of you might like it. I just show you how it looks like. How the template looks like. Here it is. Here is an example how the template looks like. See, maybe some of you might like it. So here it creates a header 2, header 3, paragraph. I prefer to have plain HTML and stick some placeholders instead of some other language to kind of learn. So, but it's still very popular. There are many other ones that you can choose from. There is another one called handlebars. There is this one that we are using. The one we are using in this example is called, let me find out. Sorry, let me just close this. Here it is. Here it is. Here it is. Here. You see here, what you do, the one we are using, the view engine that will take the template and it will take the data and generate the HTML. You choose the engine that you like. In here, the engine that we are using is called Swig. So what you do, npm install swig --save. It will be downloaded. Then you bring it in to the app using the require. And then you configure the app to use that engine. So you can plug in the engine you want. Jade, what they call it, there is handlebars, Jade, handlebars, this swing. There are many others. You pick up the one you want. And in here, have a look. You tell the app, by the way, the views, you will find them under the current directory, views. And the view engine I want you to use is the HTML engine, or basically the Swig engine. That's what this is doing. So in here you can see it's configurable which view engine you'd like to use, which template in syntax you prefer. So Jade, handlebar, and so on. Is this clear so far? Impressive? Okay.
Can I ask one question?
Yes, just keep. Yes, please.
Is this will be in homework 4?
Yes. No, that's it. That's
This
it.
is the easiest that you promise us.
No, in here you don't need to do this.
Yeah, please.
You don't need to do all of this. In homework 4, why you don't need to do all of this? You are doing it on the Angular side. You are generating the pages on your Angular or on the client side. What you will be doing on the server side, you will be doing the REST services and reading and writing from database, which will come next. So this stuff you will not be doing because you're already doing it because you're building a single page application, which means the routing and the page and the page generation and the template is defined on the client side. But you still have the server side, which would be services to read your students and actions, to do the filtering and so on. And I will show you the REST services. They look very, very similar to normal pages. REST services. It's just you get the data and you send it. You don't pass it through the view. That's the difference between REST services and web pages. REST services are read from the database and give it back. And by the way, what I was telling you that everything is JSON, based on JSON, let me show you here. When I read it from the database, it came from the database as JSON. I just took it and gave it to the view. No transformation. In fact, I could have done something like this. I could have done response dot send, and I think there is also something called JSON, is it? No. Okay, let me just do send, and I send the results without the view. Okay, I'll save. Without save, let me just it's running, so I'll stop it here. Stop it. And then I run it again. I go back there. You see here, the results are coming as JSON. This is as it is from the database. That's what it really means by the mean stack. The whole thing is JavaScript in terms of programming and JSON as data format. The same way you see it in the database through this tool. Remember this tool here? Exactly the same. You see it in here. So in your homework, you will be reading and writing JSON, but no views on the server side. These views are handled by the client side.
Can we use like SQL?
You can use it, yeah, of course. Like basically, most of the vendors, like let's say Microsoft, they will have a pack. That's why we have 200,000 packages in that npm.js. All major vendors, they have modules like similar to something like JDBC driver or ODBC driver. Module there that if you want to talk to an Oracle database, download the Oracle kind of module. And you can similar API. You submit, you connect, you submit a query, you get the results. And maybe magically they will transform those results to JSON, for example. For example, MongoDB has a module called Mongoose, and that's the one we use to connect and read and write from the database. So every database will have its own kind of module to interact with it. So really, like that's why I said one of the use cases is Node.js could be used as an API server, to connect many applications together. Because Node.js has connectors that allows you to talk to different servers, to different technologies. It's really, really powerful. All right. So let's go back. Another. Should we break here now? Another 10 minutes. So when I come back, there are two major topics. I think hopefully you got the general idea of the framework. Two major topics that you really need is how to do REST services, which kind of explained by not putting your results through the view, and how to interact with the database, in particular the MongoDB database. Yeah, and by this you will be up and running in no time. Thank you. Just resume. So just to summarize, so far we have seen with Express, when the request comes, it will come to the router first, and the router, based on the URL and the HTTP method used, it will call a particular function. Now, the actual implementation, it's recommended not to be in the router file itself, but to be outside in another file, for modularity sake. So we have seen so far that if the user comes using GET to the root of the web application, they will go to this method called list. And the list will create a query. Will create a query to get all the nodes ordered by in descending order. Only we're interested to get the top 12, the most recent 12 entries, and hopefully, if everything goes okay, what we will do, we will render one of the views. So we'll go to a view, we select the view that we want to render, and we pass it a JSON object. And the view is really a template that has some HTML and some placeholders. And the data coming from the object will be fed into these placeholders to fill up and generate the full page. That is the basic idea of Express, how it works. And this is not something new. Most of the server-side web development technologies, they work this way. They receive a request, and based on, they route the request to a particular component, and that particular, typically a controller or a model, and that particular controller or model will do some work, maybe get some data from a database, and then feed that data to a template to generate the page. That's very common architecture of most server-side web development frameworks. Now let's look at another example. In here, in the first example, the request is coming using GET, and it's coming to the root of our web application. The second example, it's also coming to the root, but this time using POST, not GET. So in here, because in here, if you remember, there is a drop-down to be able to filter. Let me refresh this guy. Now I have to go back here. Whenever I do change, unless if I do some, there is a utility called Node.js that monitors the files, and if there is any change, it will reload the page, but I'm not using it in here. So every time I do a change, I have to stop and then restart to pick up the changes. So here is the page. So this is the GET coming to the root. When you come to the root, you get the most recent 12 entries. But you can filter this based on particular member name. So in here, when I select a member and submit this, the filtering will be done on the server side, and this is a POST request. As you can see from the HTML, sorry, not this one. I need to do inspect, and you will see that there is a form here, and the method will be POST. You see here the method is POST, and the selected member will be posted to the server side. And the lucky method that will receive this on the server side is this one, filter by member. Again, it receives the requests, two very important parameters. request to get access to the parameters coming with the request, and the response to write back to the requester. So 2 objects. And this is very common. If you have used Servlet or if you have used ASP.NET, you will always see this programming paradigm or pattern where you get a handler that gets 2 objects, request and the response. So let's see how this is implemented. Again, very similar. It creates a query, and it tries to go to the request, the body of the request, and one of the elements in the body will be the member name. This is how you access the parameters that are posted to the form. Now, to be able, magically, in the Node.js is using a parser that will parse the request and convert whatever is coming as a JSON object. Now just to show you here, back to our app, you can see I am importing here a module called the body parser. This is the one that will intercept the request while it's on its way, and it will grab the form data that's coming with the request, and it will convert it to an object and hook it into the request. So if you go request.body, you get all what has been submitted from the client side. And the component responsible for this is this body parser. If I try to find where it is used, find usage, you can see here I am configuring my app to use this body parser, and I'm asking it to parse the input as a JSON object. So although when it is submitted, it will be, remember how the browser will submit it? You submit it as an ampersand delimited string. Like it will be the input name equal value, ampersand input name equal value. But this body parser will read that body and convert it to a JSON object and hook it with the request object. So from the request, you go request.body whatever property you want to get. That is how it works. So let me show you here. So I am grabbing the member name that was selected on the web page, and then I'm just doing one more test. If that filter is not null, because they might select all, which means the filter will be empty. Then, if it's not empty, I want to add a where clause to my query. So I only grab the member where the member name is equal to the member that the user have selected. And then I go ahead and execute my query. Again, this execution will be asynchronous. And when the results come back, in the future, when the results come back, I will pass them to my view, same view as before, index, and I will give it a JSON object that has the title and the notes that came from the database. Okay? And you can see here there is no transformation, objects to JSON or JSON to object. You just grab it from the database and send it off to the view. No transformation. This is the power of this framework. All right, so let's go back to the router and have a look at another one. Here is the node. Here I want to create a node. You know, when I want to create something, always there is a get to get an empty form and a post to submit the form once the user fills it in. So let's have a look at the get. In the get is straightforward. All it's doing, it's saying, please grab this view called new node and pass to it this object, which is a new node. Let's have a look at that view. Under views, you will find there is a new node here. It has nothing, this one. It just has, as you can see, it has the title, which is passed from the controller. And it has, in case there is a message, because this especially when we submit. There might be an error in this when the form is submitted. We can stick it in the message and give it back to the view. So you can see here, I am checking if that message is not empty, I will show this div. Otherwise, I will not show it. This is a conditional section of the page will be only shown if this condition is true. Then in the body of the form, there isn't anything. It's just a normal HTML stuff. Like for example, here I'm using a text box and giving it a name. I'm using for workday. I'm also using a text box. So this is plain HTML. There is nothing special about it. And if we go up here, you will see that the form has an action which will go back to /node. So when the user submits the form, it will go back to /node, new node, and the method will be post. So when the form comes back, the URL will be new node, and the HTTP method will be post. Who will receive this request first? The router. So the router will say, oh, okay, you are coming using post, and you are coming to this URL, so I will send you to this method. So this method is called create. So what it's doing, it's creating a new object, as you can see here, of type standup. And it sets the properties of that object using the data coming with the request. So it will go request.body.member_name, body.project. It constructs the object, and then it goes ahead and saves it. Save. And in here, we are not expecting anything coming back, except if something goes wrong. We will get an error. If there is an error, you can see what's going on here. I create an error message and pass it to the form. See the same node form, I'm passing to it the object. Passing to it the error message. I'm passing it a title and an error message. If everything goes fine, I will redirect the user to the home page by going response.redirect 301. This is the status code for redirect, and the URL where the user will be redirected. And this redirection will be done on the client side. So this is asking the browser, please, you finished with me, go to this other URL, which is the root. This, 301, which asking the browser to do redirect. Okay, so this will happen on the client side. Is clear so far how it is working? Yes, please. Okay, very good. Now, redirect is, you asked me to create a node, I did so, and I finished, and I'm asking you back to go back to the main page. So have a look at this. Let me go back to the example. Here it is. I go and create a new node. So when I click this one, an empty form will come. I fill it in. And save. Have a look at the URL. When I finish saving, the URL will change to /. And there will be a redirect. If you do, although I don't have any sniffer here, maybe if I do inspect. There will be a redirect. Is it on the network? Where do I see? Maybe network to see what's going on. Sorry, Nazar, where do I see the requests? Is it in the network? Network? Do I have to record? Okay.
No. What happens is if you open it after the request sent, won't you? If you refresh the page.
Okay. So let me. Can't clear. No problem. So just have a look at this. So we have a form here. I filled it in. I submit. So the router will say, okay, you are doing a post, and you are posting to a new node. So the create method will be called. Create method will pick up whatever you have entered here, create an object, and push it to the database. It's finished its work. It asks the browser to redirect to the home page. So have a look. So save, have a look at the URL will change to /. Save. And the URL has changed to the root. And if we are lucky to see what's going on here. I usually am not sure. Well, I can see the... okay. Anyway, so some client-side view. The console, okay. Okay, so here it is, but I'm not seeing. I want to see the timeline. Okay, not.
Don't look at the timeline. There is something under the timeline that should have all the records. Could you refresh just a bit?
Okay, refresh.
See the list below?
There is actually an empty selected. If you can select all, I think it will show.
Yes.
Which one? Select all. I see. Okay. Sorry, we have to do it again very quickly. So I think I got it now. Okay, so let's do another one for Fatima this time. I will just do it this way. Okay, let me now clear. And then I'll save. Come on, clear. Save. All right. Okay, it's required. So server is upset that all the fields are required, and I get a message here saying it's required. Let me try again. Although this is not the best experience, I should have filled up the form as it was before submission. Anyway, lazy developers. Okay. Now clear this, and then I'll save. Here it is. So when I save, I get redirected to the main page, and hopefully somewhere here is the redirect. The server asks the browser, please redirect to, sending it 301. 301 is an instruction to the browser to do redirection to the root. It says to here, go ahead and redirect to /. This is the location. That's what that redirect is for. Now render is something on the server side saying, okay, I grabbed all the information needed to build the page. Let me now grab the template, feed it the data, and let the view engine generate the page. So render is kind of fusing or merging the data with the template to generate the final page, and then send the page to the browser. Is clear? That is the idea. Okay. So far we have seen all the scenarios. We have seen the scenario of get and the scenario of post. We have seen how the forms, the data from the forms can be read. Very easy, request.body, and then read the parameters by name. We have seen how to read the parameters coming in the URL also by using request.param and the name of the parameter you want to read. So it's very, very flexible, very straightforward. Okay, now the next thing we want to study now is how we are dealing with the database, how the read and write is taking place between our application and the MongoDB application. So for this to work, we need some module that will help us interact with MongoDB. And every database will have its own module that you need to download to interact with that particular database. So for MongoDB, there are multiple modules that can help you do so, but the most famous one and the officially supported one is called Mongoose. This is this little fellow here. It's named after this guy, Mongoose. All right. So what you will do npm install mongoose -- safe, and it will download it and put it in your packages.json. Then, for you to use it, you have to require it and assign it to a variable. Assign it to a variable. So from now on, first thing, of course, anytime you want to talk to a database, you need to connect to it. So in here, I have put in mongoose connect, and I'm giving the URL. I'm giving, it is localhost, I installed it locally, and this is the database I want to connect to, or the database I want to connect to. So if that database is not there, it will be auto-created. If it is remotely, you can also access it, no problem. Although maybe in the QU, maybe they are blocking some ports. I could not successfully connect, but I will explore it further. Basically, there is an online cloud-based MongoDB. There are many, of course, but one of them seems quite interesting. It's called Mongo Lab. And this, you can have an online MongoDB. You have 500 megabytes, which is very good enough for development and testing. And you can basically create databases. So MongoDB is like this. You have a database. And in a database, you have collections. You have collections.
So it's schema, right?
No, schema is the structure of the document. So collections, you can think of them as the table, kind of. Okay? And the collection will have one or many documents. And document, you can think of it as the row in a table. The row in a table. Okay? Of course, when we talk about a document, so this MongoDB is a document-oriented database. Those of you who document-oriented database. It's one family of databases that tries to store aggregate object. Those of you who've seen advanced database, you have seen this before. So, for example, if you have an invoice, is this guy recorded? Oh, no. Yes. Oh. Okay. Now, if you have an invoice, for example, an invoice is an aggregate. It has a lot of information. It has, for example, the invoice header, who made the order, the customer details, the date of the order. And it has the order items. So it's a one-to-many relationship. Now, in a relational database, you will spread that in multiple tables, at least 3-4 tables. But in a document-oriented database, you keep the aggregate as it is. And you store it as one unit, and you bring it back as one unit. For example, in your project, you have the rubric. If you remember the rubric has criteria, and it has levels. And for each level and criteria, there is a descriptor. So, if you want to put it in a relational database, good luck. Multiple tables, joins, and a lot of stuff. Why should you break your head? Keep it as it is, if you wish, and just grab it as one whole, one aggregate, and store it as it is. You don't even need to give it an ID. The database automatically assigns it an ID. That is the idea of document-oriented. You don't like spread the data into a relational model, and then when you want it, you grab it back using complex joins and complex queries. Keep it as it is, store it as one unit, and bring it back as the same unit. That's the idea. Okay, so you have this nice database. You can access it. They give you They give you basically, this is the URL you need to put in your program. Unfortunately, it didn't work here. Maybe they are blocking some of the ports. So in here, if I use my username, my password, this is the server name and the port, and this is my database name. I should be able to connect and store documents there and bring them back. I will try it from home. I'm sure it will work. Okay. And then when it didn't work, I downloaded and installed MongoDB in my own Okay, so once I did this, now how do I use it? Okay, let me see. Okay, let me see this guy. This is the guy that's using it. All right, interesting. So what I'm doing in here, if I want to interact with MongoDB, first thing, I need to download this Mongoose module and load it in my application and connect to the database using the URL of the database. Okay? Then, the second thing I need to do, I need to create a model of my documents. The document collection I want to manipulate, read from, or write to, or search or find through this collection, I need to create a model that defines the schema of these documents. Okay? So, for example, in here, what document do I have in this database? In our example that we are following. Stand-up notes. Like in this stand-up meeting, I take a note, and each note is a document. What are the elements of this document? The ID is auto-generated, so I don't need to care about it too much. The name of basically the note is about whom, and about which project. So we have the, let's say, member name, project name, yesterday, today, and the impediments, like the obstacles that the member is facing. So these pieces of information. So what I do, I create a model, and then my application will start using this model to interact with the database. Those of you familiar with some object relational model, those of you who have used, for example, JPA in Java world, or entity relations in the .NET world, this is similar idea. You basically create a model, map it to your database, and then when you interact with the model knows how to read and write the database. That is the idea. But in here it's even much more simple. What you do, I want to interact with this collection of stand-up notes. So I need to create the schema basically of the documents I will be dealing with. So this is what this file is trying to do. Can you see this file is called model? So let's have a look at it. It is model. So what I'm doing here, I'll go and again get this Mongoose module. And this Mongoose module has something called schema. Don't worry about this one a bit. Okay, let me just not complicate our life. Just a second. Just cut this one. Don't worry about this, I will come back to this. Not important, not important. Okay, so I will say I want to create a stand-up schema, which is defining what is the structure of each document in my collection. So in each document will have these properties. I have a member name, it's type string and it is required. I have a project string and required. As you can see here, I'm defining all my schema all the attributes, and also created on it is date, and it is by default it will be not it will be the current date. If I don't supply it, it will be the current date. I also can specify some validators. Remember before when I filled up the form and submit and I didn't provide the required field, I get some error. So before the actual document is persisted, this schema will be used to validate that the message, that the instance, I have the concept of a schema and a concept of instance. So when I create an instance, before it gets pushed to the database, it will be validated against these rules. So I can have rules like built-in, like required equal true, and I can have also custom rules, custom validation rules. For example, here I have this custom validation rule called required string validator. And you can see this required string validator is an array that has the validation function and the error message. Okay? So the validation function, it takes the value that's the value of the actual property, and it says, okay, get rid of any spaces and check. I'll be happy if it has some content. Otherwise, I will throw this message, and this message has the path is basically referring to the property being validated. Could be member name, it could be yesterday work, today's work, could be any of the fields that is referring to this validator in the validator property. So very nicely done. So you get the idea. There is another one called member name validator. Here is the member name validator. Again, it's an array. The name validator, it should have some content, and it should not be called none. It should not be equal to none. Otherwise, I will be upset and say, no, please select some validator, some member. You cannot select none. So that is the idea of a schema. So I create a schema, and then based on the schema, I create a model based on that schema. So these are the steps. I grab my Mongoose module, load it in my application. Then from the Mongoose, I can create a schema that describes the structure of the document. From the schema, I create a model. That's it. From that model, I can read and write to the actual database. Okay? The model has built-in logic. It knows how to read and write to MongoDB. Now, I am exporting, as you can see here, this module is exporting to the outside world. It's exporting a model called stand-up. Okay? Exporting a module called stand-up. And this module stand-up has this schema called stand-up scheme. Now, here is how I use it. Let's take the simple example. If I want to find, have a look. If I want to find all the documents in the collection, I come to the model and say find. Okay, I can just do find.execute. It will execute and get me everything. Or I can further add some further qualifiers on the query. Say, okay, I want you to sort, I want you to limit to the top 12, then execute. In here, in the second scenario, I say find, and I do sort, and then I do where clause. So it's a very powerful way of building your query and basically customizing it. Instead of writing your SQL, normal SQL statement, this is how you do it, imperatively. Now, if you want to save, here is how you save. So what you do is you go and say, okay, please create for me a stand-up object, fill it up with the data coming from the form, and then go to that entry, the new instance that you created, and just call save. That's it. It will be saved. That's how it works. Very, very transparent and very simple. That's the story of the mongoose. Very straightforward. And you can start with nothing, basically, just a connection to the database. And the collection will be created automatically, the documents will be created, and so on. Yeah. All right. So the last part, which is very critical for your project, is using REST services, which is exactly the same what we have seen so far, except we don't need to do views on the server side because the views are already on the client side. We just want to get the JSON and plug it on give it to our view to show the information. So, which in another words, currently what you are doing, you are reading from the file, which is very unreasonable, not realistic. So your code on the client side will not change. You will only change the URL. Instead of, let's say, student.json, you will say /localhost 8080/students, for example, to get the list of students from the server side. And when you are creating a new action, you don't go to the collection, add it, and then put it in the local storage. You will say, you will call a service to do post request, and you give it the object, and it will be persisted. This is the idea. All right. So for the REST services, I have another much simpler example. Here are the REST services. Let me first run them, and then I explain. Let me stop this guy. And this is another example. It deals with books. Very simple example. Let me run it, and then I will explain it. Run. Strange, I didn't put. Okay, somebody is listening on this port. All right, somebody is listening on this port. Who is listening here? Okay, maybe this guy is listening. Or I can change the ports. If it still doesn't work, I can change the port. Or let me try. Okay, so I will do CD 6. All right, and then I will do gulp. This. All right, so my application is up and running. I hope so. Failed. What is the problem? MongoDB unhandled error. It's not able. Oh, I closed my MongoDB server. All right, no problem. Okay, the MongoDB basically lives in. Sorry, I'll have to find it. I think under program files. See, program files. I recommend not to install it under program files. It's not very good. It's the MongoDB server 3.2 bin. Okay, grab this location. Grab this location. Go and open your shell. Any shell you wish. All right, go to that location. All right, and then /, I think Mongo. Not sure which one is the one. MongoD. I think MongoD. All right. So my server is now up and running. And let me now go back here. Go back to my app. Stop it.
So you're not using the mobile app, right? You're just using a local.
Yeah, local one. I think it's network issue. I was not able to connect to it. Yeah, remotely. I can do everything on
Depends
this
on the port, right?
report. Yeah,
If it's not 80, forget it.
it's not it. You can. Oh, okay. I see.
Unless you have a special request from the phone.
Oh, yeah. It's a bit sad. I wish we could do that, but I will try it from home. Okay. So where I am, I basically do here C6 REST services. Then I do gulp to start it. So hopefully everything will be fine. It's listening on port 8000. So if I go to localhost 8000, if I just go to the URL, to the roots, there's nothing in there. It just says welcome. But really the API, I put it under, it's good practice, very commonly used. The human web, you put it under the roots, but the programmatic services that will be accessed by other programs, you put them under a different URL, like slash such as API. And then you say, let's say books. Okay, I have there 2 books now. So REST services exactly like, they behave like web pages, except you push to them JSON objects and you get back JSON objects. There is no UI because you access them programmatically. So I can ask for a particular book by ID. I can do slash this. Okay, and I get that particular book. If I wish, I could also now if I can also do delete, I can do update, create new ones. But in here I cannot do this through the normal browser. I need to use an kind of another tool or a write program to read and write using these REST services. In your case, you will test them using something like Postman. This is the best one. Here is Postman. I think maybe it's already open. Where is it? Oh, here, sorry, it's already open. Yep. So what you do is you go to a particular URL. This is a plugin. You just look for it, Postman. And then you choose the method that you want to use to interact with the server side. And then you send your request. Here is the reply. Sorry?
What's the name of the plugin?
This one is called Postman. Like here. This one. Postman. Yeah. Postman. The Postman. I know we don't see them much. We don't see them often. That's why. البوست البريد ساعي البريد. Yes? Okay, so you give it the URL, it gives you back the JSON. Okay. Now, what you can do, if you wish, you could copy this, and you want to change it. Let's say we want to change it. Then, in this case, I will do post to basically update it. So here it is. I don't put the ID. I am putting the ID. No, I have to do here. Sorry, param. I'll do param and I'll do the body of the request. And I'll say row. So let me just put this one here. I don't pass this. And I don't pass this. So basically, I want to update this book with these new details. Just to say that I have read it. And it's called Node.js REST services. Okay, so I do send. It didn't like it. Not found. Okay. Oh, sorry. It didn't like it. This post not found. Okay. So let me try. Okay. In this case, let me try to add new one. Just to show you, let me try to add new one. For the update, I have to have a look what is the URL. So if I want to create a new one, I post it to /API/books. And here, Node.js, someone, all right? And this I'll call it web programming and true. Okay, and then I'll do send the request. It is sent. You see, everything went okay, and I will get a confirmation with HTTP status code 201 created. And I will get back the object that was created with the new ID. Okay? And in fact, if I go and do another get, I should see that new book I just added. Here's the new book I just added. Okay? So REST services are, the formal definition are some components remotely accessible and you interact with it using HTTP. If you want to read from it, you send it a GET request. If you want to add a new item to that resource, you send a POST request. If you want to replace it, you send a PUT request. If you want to do small change, you send a patch request. If you want to remove it, you send a delete request. So you are using HTTP verbs as your API. This is basically the idea of REST services. So the basic idea is three major elements that a service has. So a service has a URL. It has an address, a particular address. It has an interface, but this interface is universal. All REST services of the world have the same interface. What is this interface? HTTP verbs. Get to read, post to create, put to replace, patch to update, and delete to remove. So there is a uniform interface. Uniform interface. And this interface is nothing but the HTTP verbs. And the resource, when you get a resource or send a resource, you are sending a resource using a particular representation. In the past, it was kind of XML. XML is kind of phasing out. And now, really, it is more about JSON. So these are the main ones. Plus, there is another one called another tenant or another principle called, or another element of this idea of REST services called hypermedia, where when you get a resource, you also get links either to other resources or to other actions. Like for example, when you book a flight, you get the booking details plus a link if you want to cancel that flight. All right? So that's called hypermedia, which means whenever we get a resource, we also get relevant links to do some actions on that resource. This is nicely explained in the slides, no problem. All right, so now let me show you the program inside of it, very, very quickly. Here it is. Here's my app. As I explained before, I need the Express because the whole framework is built on Express. That's why, if you remember, we have the mean stack. If you remember, Mongo, Express, Angular, and Node. So Express is a very important module. In fact, if you go to NPM, is one of the top modules that is being downloaded. One of the top. Okay, Mongoose, you know the role of it is to interact with the MongoDB. Body parser, what the body parser is for?
Parse the body into JSON object.
Yes, thank you. When the incoming request coming in, maybe it's coming as a form, magically it will be translated to an object and sticked into the request object. All right. So here is how I create an Express app. Here is how I create a web app. Just I do app equal Express. I decide my port. Either it is pre-configured from the environment or I choose the port number. Here I'm just configuring the body parser. I want to parse whatever coming in as JSON. And then I say, oh, by the way, my routes are not defined. I could come here and define the routes, but I'm not defining them. I could come here and define my routes if I wish, but that's not a good idea. Instead, I am defining my routes in a separate file. Which file is this? Routes, book routes. In there, I put my routes. When I put them, I come and say, oh, by the way, use these routes and make them available at this URL. So this is my web app, and I am configuring it. Okay, you can think of it as a web application is a composition of different modules. Some modules are coming from Node.js itself. Some modules are downloaded using npm, okay? And some modules I create myself. All right, so let's have a look at these routes. Here is the routes. So this route, what I'll be doing, I go to Express and say, create for me a router. And then I'm configuring the router. If somebody comes to if somebody comes to route to the root of my app using post, what I will do, simply what I will do, I'll create an object and save it. I return back 200 OK, 200 created. And also I will return the book that has been created. Can you see what's going on? Very, very simple. Because the object is already coming as a JSON object. It's in where? In which part of the request? It's in the body of the request. Grab it and save it. No change. That's what I mean by JSON all along. No data transformation. Just JSON all along. Save it, say to the client, don't leave the clients uncertain what's going on. Tell them what's going on. Tell them that everything went okay and whatever object they have requested, it's created. 201. Don't send 200 okay. It's not too bad, but 201 is perfect one when something is newly created. All right. Now, if somebody comes using get, what we will do, there are here two scenarios. If they just come with get and there is no parameter, they didn't supply any parameter, I will just grab everything and give back to them. But if there is a parameter called John, I don't know how to read it in English. Okay, so what I will do is I will, where do I put it? Yes, here. I'll create I'm saying to the query, only give me the books where this attribute is equal to the one that the user is asking for. Okay, and then I go and basically do find, go to the book and do find, give it the query. If everything goes okay, I will get the books and I will just return them to the caller by using response.json and give it the JSON objects. All right. If something goes wrong, I'll give them 500 server error and pass this error to them. Can you see what's going on here? So this is how I handle the get. Khalas, this route is now handled, no problem. If somebody comes to the root using post, a new book will be created. If they come using get, they will get either all the books or the books belonging to a particular category. Now, what if they come using slash plus a parameter, which is the book ID? In here, there is a new trick in here. Let me first try to explain it through here. Let's say somebody comes using get and they ask us to give they ask us for a particular book, So all we need to do, we will grab the book and send it off. Now, if you look here carefully, if I want to update or patch or get, I will have to read first. If I want to update something, I always have to read it first before I update it. So get and put and patch, all of them need a read first. Are you following?
Yes.
So instead of repeating the read in every method, instead of repeating the read in get and then repeating it in put and repeating it in patch, you see here there is a patch, and repeating it in delete. Instead, what I'm doing, I read it once. Have a look at this. So in Node.js, there is something called the request processing pipeline. When the request comes, it goes through a series of steps to process it. So you can configure this pipeline and put some methods along the way. This is not new. All web servers have this concept of a request processing pipeline. So in here, instead of using get or post or delete, I'm using here the keyword use, the method use, and say if anybody comes with slash followed by a book ID, first go and grab that book. Can you see here? Get the book from the parameter and find the book by ID. Find the book by ID. And what do we do with the book? We attach it to the request. And then we move to the next step in the pipeline. What is the next step on the pipeline? It depends whether it was a get method or put or delete. So this is called, in a Node.js terminology, this is called middleware. I don't really like this name. A request processing pipeline is more appropriate terminology. But they call it middleware, which all it means, do this work and move next. So it's a middleware or a request handler is similar to normal request handler, but it has this extra parameter called next. So you see here, if there is a problem, do I do next? I just stop it there. If there is a server error, do I do next? No. So you see here, for error handling, I use one generic error handler in front of my routes, and it will, if there is an error, I don't need to handle it in all the routes. I handle it once. You get the idea. Okay. So this one is doing many birds, one stone. One is I'm centralizing my error handling in one place, and I'm not repeating myself with regards to reading the book details. I read it once. Stick it into the request and pass the request to the next. Pass the request to the next handler. Now the next handler is the one, any handler that comes after this in the actual file. Any handler that comes after this will be the lucky one to receive it. Now in here, if it is get, all I need to do, grab the book and send it off to the requester using the response. If it is put means somebody is asking me to update, to replace. Put is basically a replace. So I go to the request, grab the title, the author, the genre, and the read, and then update my object, and then save my object. Okay. If it is patch means I only change one part of the object, not the whole object. This is what patch is. Okay. And then delete, this is what delete is. Remove, basically. I'm going to request book.remove. That's it. This is what In here we don't have a controller. I hard coded this. This is not very good. I hard coded the logic in the router. This is not very good. You should push this into another file to do the actual logic. The router should only map a URL to a mapping and not actually do the work. That's it. Of course, for dealing with the MongoDB database, as I explained before, you must have a model. So for the book, I'm creating a schema for the book and then creating a model out of that schema. And that's it. From that, I can use the book model to save, read, delete, and update the documents. That is basically in a very concise way what Node.js is all about. So I'll be sending you the draft, kind of semi-final PowerPoints tonight with these examples. And then we'll take it from there. Thank you very much, and sorry for keeping you a bit longer, but we started a little bit late.